The reason I can eat so much chocolate and not gain any weight is because I'm sitting here thinking high-calorie thoughts. Today is awesome day. I had an original thought that nobody has had before. I even Googled it and nothing came up. So, you know, genius. Let me tell you about it, okay? Now, I'm gonna assume, wow, let me eat this chocolate. I was gonna do a video about how astronauts pee in space. It's actually kind of hilarious. They take their penis and they put it into like a condom thing, which is attached to a hose, which is attached to an airlock. They pee into the airlock, seal it on this side, and then open it to the other side, and the vacuum of space just sucks it out. Which is hilarious if you think about your penis being attached to a hose which gets sucked out into space. If there's some sort of malfunction, it would feel awful. Or wonderful. Hard to say. I was gonna, maybe I should put my penis in a vacuum cleaner and see how that would... That is a horrible idea! But also one of the greatest things I've ever experienced. Instead of doing that video, I came across an interesting study that NASA just did with twins. They had 2 twin astronauts, and they kept one twin here on Earth, and they took the other twin and put him up in the space station. And he just kind of flew around the world for like a year. And then they studied the effects that space had on the human body. You know, in like a long-term space travel sort of a thing. What they found, bone density loss, the guy got a little taller, there was a lot of stuff negatively. Space is bad for you, it's just bad for you. But on a cellular, chromosomal level, something awesome and unexpected. You ready? Scott, the astronaut's telomeres, the ends of the chromosomes in the DNA got longer. See, each time your cell divides, the telomere in your chromosome gets a little shorter, to the point where the cell can no longer replicate chromosomes and itself, and the cell dies or becomes some sort of cancer. So the longer your telomeres, the more life you have left, because the more times your cell can continue replicating. Old age is your cells not replicating properly, and like when you hurt yourself, your cells fix that and replicate and fix it. But if you're old and you hurt yourself, the cells have been copied so many times that they're just like, and they can't, and you just die. That's what old age is. It's your cells not replicating and you die. Sorry, happened to everyone, even me, one day, maybe tomorrow. But Scott's in space got longer. Now, why? Why did this happen? Scientists theorize that it's because Scott was exercising more and eating diet. They have seen people's telomeres get longer with the exercise and diet here on Earth, so they're saying, oh, that happened in space. But it's not yet clear. They note, however, that the changes in Scott's DNA, in Scott's cells, are greater. Seem to be larger than normal, perhaps due to the stress of eating freezer-dried food and trying to sleep while floating in space. But I don't think that's the real reason. I don't think that's the real reason. I don't think that they may be a contributing factor, but I don't think that's the real reason. I have my own theory. My own postulation, if you will. And for my theory, I turn to time dilation. Follow me? What is time dilation? Okay, without trying to catch you up on how time was invented, sundial, mechanical clock, quartz clock, atomic clock, I'm gonna jump into the atomic clock. We're counting seconds. The way an atomic clock registers a second is it counts the frequency or vibration of an atom of the element called cesium, maybe. I don't know, I've never heard it, I just kind of read it, cesium. 9,192,631,770 frequencies, little wavelengths, equal 1 second. And since 1967, that has been the most accurate measurement of time that we have. Why is this important? Well, part of the special theory of relativity and the general theory of relativity is that time slows down as you go faster and approach the speed of light. Time dilation, time slowing down. The way they measured this and proved it was they took an atomic clock and put it on an airplane and flew it at 750 miles an hour around the Earth like I think it was 6 times, but I'm not exactly sure. And they took an identical atomic clock and just left it here on Earth. And when the atomic clock came back, they looked at them both and said, is this one running faster or slower? And in an eastwardly direction, it was running slower, to 59 to the power of 10 nanoseconds slower, which is a very tiny amount. But because it's an atomic clock and they're measuring seconds with these huge numbers, you can actually find that amount. So time dilation is real. Interesting is that human beings are clocks, right? And how would you measure your clockiness, right? Your heartbeat? No, that's too irregular because you start running, whatever. How many breaths you take? Tick-tock, tick-tock, no, because you can hold your breath. And if you hold your breath, that doesn't exactly stop time, does it? No, it doesn't. How about cell division? How about that? At some point, not necessarily how long does it take your cells to divide, but how many times can your cells divide? It's like a different type of clock. It's like a biological world human being clock. So when Scott went up to the space station and like docked with them, the space station is actually traveling at 17,150 miles per hour. Google to the rescue! 17,150. God damn, I'm good. God damn. How did I know that? Astronomy. Almost 9 years, no, longer than that. God, I'm so good at that. So good at that class. Anyway, time dilation. His biological internal clock of cell division, where cell division is the second hand, slowed down, creating longer telomeres, which increased his life because his cells could replicate more. Does that even make sense? Or am I just fucking retarded? Just putting two things together that don't belong together. If you're a human being, if you're a clock and you were traveling in an eastward direction, you would slow down. So the rate at which your body decays would slow down. So you could say that the decay of the atom in the atomic clock is slowing down, just like the decay of the human being is slowing down while it's traveling at an incredible speed. This would also push in the general direction a postulation or proof of the twin paradox that Albert Einstein and Max Bohr were wrestling with back in the day. Why the twin who was traveling came back wouldn't be any older than the twin that stayed on Earth, because it has to do with velocity. They postulated that aging had a direct effect from velocity. I think that is what NASA has just stumbled upon, but they haven't put it together yet, like I just did. So, boom! I can't do the math on it, but the guy that does is gonna get a Nobel Prize. And I just wanted to put this video out there to be like, I had that idea first, bitch! But maybe I didn't have it first. Maybe he had it last night, and I'm just independently coming up with it by myself. The implications of this are amazing though, because as we approach the speed of light, our lives will, on a cellular level, get longer. On a cellular chromosomal replicating level, get longer. Maybe to the point of immortality. I mean, if you're going fast enough. And that would make space travel possible, at warp speed. We would actually be traveling through space and time on a quantum physical level. Huh! Okay, I have to go now put my head on a block of ice. I need some more chocolate. Who needs exercise when you've got brain chemistry burning all the calories? Mind equals yes. Thank you for watching. Thank you for working through this with me. I think I'm right. Could be wrong. I'd love to hear your thoughts in the comment and, continue this conversation. What do you think about space travel and shit? Final summation. NASA's twin study, being examined, has found that space appears to alter the way our cells process basic genetic information. But I would argue that it isn't the space that's doing it, it's the speed at which the person is traveling, in a quantum physics time dilation sort of way. So if you know anybody at NASA's human research program, do send them this video, because I'd be very curious to hear what they think. Anyway, I love you, my little lemon drops. Sign up on the email thing on my website so I can send you an email when I come to visit you. And send me some money because, you put something on this wall behind me. And eat. I love you. And if you believe me, it's gotta be true, right?